Welcome to section 8.5, quadratic functions and their graphs. Our goal in this section is to graph quadratic functions in various forms. A quadratic function in standard form looks like this. Some function equals ax squared plus bx plus c. For instance, you might have y equals 7x squared plus 2x plus 3. The graph of a quadratic function has a distinctive U shape that we call a parabola. You may have seen it before. If your leading coefficient, a, from up here, is positive, then your parabola will open upwards and it'll look like an upwards facing U. If your lead coefficient is negative, then your parabola is going to open down and look more like this. Probably the two most important features of a parabola are the vertex and the axis of symmetry. The point where the graph turns around is called the vertex. So for instance, on my two graphs here, you can see that this one has a vertex at what looks like maybe is 3, 2, and this one has a vertex also at 3, 2, but it's flipped over. The axis of symmetry is a vertical line that chops the graph of the parabola into two identical halves. So for instance, on this graph, I could sketch the axis of symmetry right through there. This line has the equation x equals 3, since it's a vertical line going through a point where x is 3. This guy has the same axis of symmetry, that vertical line that cuts the parabola right in half. The vertex form of a quadratic function is this. Function equals a times x minus h squared plus k. Compare that to the standard form of a quadratic function, which we saw a little bit ago is ax squared plus bx plus c. So they're similar, but different. They're both quadratics. They both have an x that's being squared, and it's really just two ways of expressing the same function. Now what I'd like to do is go experiment with the values of a, h, and k to see how they affect the graph. To Desmos.com. You can see that over here I have the vertex format of a quadratic function. So I have y equals a times x minus h squared plus k. Down here I have little sliders that let me change the values of a, h, and k. And then the graph appears over here. Right now I have h and k set to 0 and a set to 1, which means that this is really the same function as just regular old y equals x squared, which you can see in the purple now. I'm going to leave y equals x squared up there so that we can see how these other graphs compare. I'm going to start by experimenting with the value of k. So let's go ahead and move k up and make it a little bit bigger. Let's say we make it 2. You can see over here now my k is 2. So I'm adding 2 to the end of my regular x squared. And you can see it's shifted the graph up by 2. If I keep making k bigger, it keeps moving the graph up. And if I make k negative so that I'm subtracting something off of my regular x squared, it moves the graph down. So it's this exact same shape, it's just shifted up or down a little bit. It's moving the vertex of this parabola up and down. I'm going to go ahead and put k back at 0. And now I want to look and see what h does. So I'm going to start by moving h to the right to make it bigger. So now I'm subtracting an h, and hey, that makes the parabola move to the right. And if my h value is negative, my parabola moves to the left by that much. Okay, I'm going to set my h back to 0, and now I'm going to manipulate my a value. There are two things that I want you to see about the value of a out here. The first thing is, if I slide all the way over here and I have a nice big A that's bigger than 1 and positive, it makes my parabola really skinny, tall and skinny. And the bigger the value of A, the taller and skinnier that parabola gets. Now I'm going to put my value of A in between 0 and 1, which takes a little bit of work over here. There we go. So you can see now that my parabola is getting sort of shorter and fatter as I have the value of a between 0 and 1. So that's one thing that I want you to notice is that if a is bigger than 1, you get a tall, skinny parabola, and then if a is between 0 and 1, you get a short, fat parabola. And now we're going to make a negative. Let's make it a bigger negative number, something like -6. Look, it flips the parabola over, and it makes it, if I have a bigger negative number like -6, it makes it tall and skinny, but flipped over. You can see it a little better here. And if I make my value between 0 and -1, it's still flipped over, but now it's kind of fat and short, the way that the other one was. So if the value of a is a negative number, it flips the parabola upside down, so it's opening upside down. Go back and write down our observations. I want to go through this just one more time. When I move k up, so when I have a positive value of k, it moves the vertex of the parabola up by that much. If k is 3.2, then the vertex of the parabola moves up in the y value by 3.2. And if I subtract a k value, it moves it down so that I have, say now, a vertex at 0, -4. If I take my h value, notice that h is being subtracted. So if I subtract h, it moves it to the right. So for instance, now, let me move it over here, my vertex is now at x equals 6, y equals -4. I can move my h back this way. If my h value is negative, that would make me add something in here. Then my vertex will be shifted to the left. So now my parabola has a vertex where x is -5 and y is -4. Finally, the value of a does two different things. If a is negative, it flips the parabola over. If a is big, a number that's bigger than 1, it makes the parabola tall and skinny. It could be tall and skinny facing up, or tall and skinny facing down. If my a value is between 0 and 1, it makes my parabola short and fat. It could be short and fat facing up, or it could be short and fat facing down, like this one. Now I'd like to just make a note of what we learned from that experimentation. First, let's look at what a, h, and k do to the graph. The first thing we noticed was that k shifts the graph up and down, so it changed the y-coordinate of the vertex. Next, we notice that h shifts the graph left and right, so it changes the x-coordinate of the vertex. Finally, we saw that a stretched the graph. A large value of a made a tall, skinny parabola, while a small value made a short, fat parabola. The a value also decided whether it opened up or down, whether or not a was positive or negative. At last, let's summarize that information before we go ahead and do some examples. When I have an equation in vertex form, the vertex is really easy to read off of the graph. Remember, k moved the vertex up by k, so that changed the y value to k. And the h moved the vertex left and right by h. So the vertex of my parabola is at hk. One thing that's really important to notice here is that it's minus h, but actual h is the number that goes over here. So be a little bit aware of that negative sign. Then the axis of symmetry always goes through the x-coordinate of the vertex. So the axis of symmetry is x equals h, whatever that happens to be. If a is bigger than 1, then you'll have a tall, skinny parabola. But if a is between 0 and 1, you'll have a short, fat parabola. And finally, if a is negative, the parabola will open downwards instead of upwards. Now let's look at an example that has some actual numbers in there for a, h, and k. Without our calculators, what can we figure out about the graph of this function? What's the vertex? It's a good place to start. So since I have x minus 2 inside here, the x-coordinate of the vertex is 2. And so I've got a plus 3 on the end, the y-coordinate is 3. So the vertex happens at 2, 3. The axis of symmetry goes right through the x-coordinate of the vertex, so it will be the line x equals 2. Is this guy going to open up or down? Well, I've got a negative value out front. A is -1/3, so this guy will open down. And then, because 1/3 is between 0 and 1, this is going to be a short, fat parabola. Finally, let's go ahead and make a sketch of this thing without using a calculator. I'll start by putting down all of the information that I currently know. I know that the vertex occurs at 2, 3. So x is 2, y is 3. There's my vertex. I know that this opens down and that it's sort of short and fat. But I can do a better job than that. I'm going to make a table of values, fill in some numbers, and then plot those points. To get a couple more points on my graph, I picked a few net values for x that I'll plug back in here to find out the corresponding value for y. I'm going to show you how one of those goes. If x is -1, then f of x, or y, is -1/3 multiplied by -1 minus 2 squared plus 3. Now this simplifies to -3 squared plus 3, and -3 squared is 9, so now I have -1/3 times 9 plus 3. -1/3 of 9 is -3 plus 3, which is 0. So I can say that when x is -1, y is 0. So I can go ahead and graph that point. When x is -1, y is 0. That's this point right here. Now remember that the axis of symmetry cuts the parabola perfectly in half. So if I have a point that is 3 away from the axis of symmetry and sits here where y is 0, I must also have a point on the other side in exactly the same spot. So it looks like the point 5, when x is 5, must correspond to a point where y is 0 in order for my parabola to have that nice symmetry. So if we use the axis of symmetry, we get 2 points for the price of 1. Knowing that -1 spits out a 0 also tells me that 5 must spit out a 0, so that this parabola can be nice and symmetric. Okay, let's go back over to my table and fill in a few points. If I plug in a 2, I'm going to get 3 out for y. Now you can do that by plugging the 2 in for x and then finding out that you get 3 for y, but we actually already knew that that point was on the graph because it's the vertex. Also, if I plug in an 8 for x, I'm going to come out with a -9. Let's go ahead and plot those points and see what we've learned. We already have the vertex on here, 2, 3. And then if I come over to where x is 8 and down to where y is -9, I can plot another point. Now, this point here needs to have a mirror image over here. So let's take a moment and see if we can figure out what that mirror image needs to be. If I think about flipping this point over the axis of symmetry, I notice that my point is 6 away from the axis of symmetry, which means that there must be a point on the other side that is also 6 away from the axis of symmetry. Just counting over, that gives me a point that sits here at -4, and y is -9. So there's one more point that has to be on my graph. Now I've got an awful lot of information about my parabola on here. In fact, probably more than I really need to get a good sketch. I've got the vertex, the axis of symmetry, and a couple more points, so now I can connect it up in that nice U shape. Notice that my parabola did end up opening down because of that -1/3. It's a little bit spread out compared to what the graph of x squared would be, and the vertex is at 2, 3. So all that information that we figured out just from the equation does show up back here in the graph. Now I'd like to do a couple more examples of finding the vertex and axis of symmetry for a quadratic function, and then doing a really quick sketch of the graph. My first example is y equals x squared plus 5. Now this doesn't look just like the example that we did before. It's actually meant to be a little bit simpler. What's happening here is that the value of a is 1 and the value of h is 0. That makes my vertex just 0, 5. What's happened is that this has been moved up 5 units, but it hasn't been moved left or right at all because there's no h value here. That makes the axis of symmetry just x equals 0. The axis of symmetry is always x equals the x coordinate of the vertex. Now, let's do a rough sketch, a little more rough than the last one. I just want to identify the vertex and then whether it opens up or down this time. So my vertex happens at 0, 5. So I need to go x is 0, and then I'll move up 5. 1, 2, 3, 4, 5. And then this opens up, and it's about as skinny as a regular x squared parabola would be. My second example is y equals x plus 5 squared. This time a is 1 and k is 0. Now it's going to take us a second to figure out what h is. Remember that vertex form is y equals ax minus h squared plus k. So I know that the k is 0 in this case, but this h is really a negative 5. You can think of this as y equals x minus negative 5 squared. So my vertex happens at negative 5, 0. And the axis of symmetry is x equals negative 5. Again, let's just draw a quick sketch, just a rough sketch. My vertex happens at negative 5, 0, so I need to move left 5. 1, 2, 3, 4, 5. And I don't need to move up at all. There's my vertex. This guy will open up since a is positive, and because a is just 1, it will look the same shape as a regular x squared parabola would. My third example has all the things going on. We've got an a value of 1/4, h is negative 2, and k is negative 3. So that tells me right away that my vertex is negative 2, negative 3. And the axis of symmetry is x equals negative 2. Again, let's just do a quick sketch of this. I'll start by putting my vertex on. The vertex happens at negative 2, negative 3. It looks like my parabola opens upwards since a is positive, but it's a little shorter and fatter than a regular x squared would be. So I'm going to just do a really rough sketch and kind of draw it short and fat. If we wanted to be really careful and precise, we would plug in a couple more points for x and find out the corresponding values for y, and then plot those points. Now, of course, I have a couple for you to try. So I want you to find the vertex, the axis of symmetry, and then draw a rough sketch of each quadratic function. Just make sure that you get the vertex on there and whether or not it's opening up or down. Go ahead and pause the video, give these a try, and then we'll come back and talk about them together. And we're back. Let's take a look at these together. Here I had y equals x squared minus 2. In this case, the h value is 0, and the k value is negative 2. So the vertex is at 0, negative 2, and the axis of symmetry is at x equals 0. Notice that that's actually the y-axis that cuts this parabola in half. I drew a quick sketch. The vertex is at 0, negative 2, and it opens upwards, and it has about the same level of openness, or shortness, or tallness, or fatness, or skinniness as regular x squared would. Now I have y equals x minus 3 squared. This time h is 3, positive 3. Notice it's the opposite sign of the thing inside. And k is 0. So my vertex happens at 3, 0, and the axis of symmetry is x equals 3. For my sketch, I drew in my vertex, and then I noticed that it opens up since a is 1, and it has about the same level of steepness as a regular x squared would. And then over here, we had 3 times x minus 4 squared plus 1. The vertex is 4, 1. Again, notice that it's regular positive 4, not negative 4. The axis of symmetry then happens at x equals 4. So that's the line that I could draw that would cut that parabola in half. For my sketch, I drew my vertex, which went over 4, up 1. And then I noticed that that 3 out front is going to make this a tall, skinny parabola. So I drew it nice and tall and skinny. I have a couple more examples just to make you think a little bit. First of all, think about what the graph of x squared plus 32 would look like. And then I'd also like you to think about what the graph of x minus 45 squared would look like. I'd actually like you to take a moment and think about that before I write down my answers. All right, have you got an answer? For my first graph, x squared plus 32 is going to have the same shape as x squared, but be moved up by 32 spaces. The vertex will be 0, 32. That plus 32 on the end moves it up. Here I have x minus 45 squared. That minus 45 is going to move it 45 spaces to the right, which I know feels a little opposite because of that minus sign. It's going to have the same shape as regular old x squared, but 45 spaces to the right. The vertex will be 45, 0. And finally, another question to stretch your brain a little bit. The graph of a quadratic function is shown here. If you know that a is 3, I'd like you to try writing down the vertex form of the quadratic function. Remember that the vertex form is y equals a times x minus h squared plus k. Now I do want you to take a moment, look at the graph, and see if you can figure out how to fill in those pieces from the graph. So, did you come up with anything? The first thing I noticed is that the problem said that a is 3, so we can fill that in right away. We know that y equals 3 times some other stuff. Now, I'd like to know what h and k are. Those come from the vertex, and on my parabola here, I can actually read the vertex right off. The vertex is happening at -1, -4. So that means that h must be -1. But remember, this is minus h, so minus -1. And then k is -4, so this is plus -4. I'm going to clean this up and write it a little bit tidier. The equation for this parabola is y equals 3 times x plus 1, since it's minus a -1, squared. And then plus -4 can just be written as minus 4. Well, that wraps us up for section 8.5, Graphs of Quadratic Functions. I'd like to really encourage you to go play around with Desmos.com. Desmos is free, and it provides you with a nice visual example. I really think that messing around with those graphs and their equations can help you develop a strong intuition about how things ought to work. Finally, Desmos is really beautifully put together, and if you explore a little bit, you'll find not only some neat tutorials that people have made, but also some really beautiful pieces of art that people have made using Desmos. So have fun exploring.